this integral can be solved by trig substitution. So strategies I'm sharing here is trig substitution. What happens is that we will try to convert this in terms of trig function and also in terms of d theta, and then using the trig ratio we'll revert it to the to the x and in terms of x. There you go. So we're gonna first let x equal 2 sine theta. And why 2 sine theta? Well, notice that that would be a squared minus x squared. Anytime you see this a squared minus x squared form, you take the sine theta. And don't write the 4 in front of sine theta. It simply takes a, not a squared. And every time you set x equals something in integration technique, you simply take a derivative. Dx equal 2 cosine theta d theta. But then you might wonder, what do I do with the x squared on the top in the numerator? Well, since I said x equals 2 sine theta, I can simply square both sides. Therefore, I will get x squared equal 4 sine squared theta. Okay. Now notice that I can simply substitute all these. That's why I call it substitution. And we're using trig functions. So let's plug them in. So integral of x squared is simply 4 sine squared theta over 4 minus the 4 sine theta, sine squared theta, and it's to the 3/2 power, and don't put dx, we replace it with 2 cosine theta d theta. Therefore 2 cosine theta d theta. Okay, looks all good. I will try to pull the, what's that thing called? Coefficient, yeah, coefficient in front of the integral, and that becomes 8. Integral of sine squared theta cosine theta d theta, and on the bottom I can have 4 pulled out 1 minus sine squared theta. So notice we have 2 parentheses and that. Let's make it, that wasn't good. Okay, much better. And this integral is kind of misleading, therefore I'm going to have a bigger integral that incorporates both top and bottom. And notice the 1 minus sine squared theta. That's from the trig identity from algebra 2 trig, or maybe in pre-calc. That's a cosine squared theta. That is derived from 1 plus, sine squared theta plus cosine squared theta equals 1. And if I simply subtract the cosine squared theta on both sides, I get 1 minus, no, I'm sorry. If I subtract the sine squared theta on both sides, I simply get the cosine squared theta. So I can replace the inner parentheses with the cosine squared theta. Alright, so I have cosine squared theta and then 4, and I have a parenthesis with 3 to the half power, and then 8 is in front, and sine squared theta cosine theta d theta. Let's actually multiply or get rid of the power on the denominator. 4 to the 3/2. Okay, I can first try 4 to the 1/2 and then cube it. This is simply 2 inside the parentheses. 2 to the cube, I get 8. And then cosine, in the same manner, cosine squared theta, and then you have 3/2. squared and then that 1/2 power is gonna cancel out. So that leaves me only cosine cube theta. So I'm gonna have 8 times cosine cube theta, and on the top I have sine squared theta, cosine theta, d theta, and then outside I also have 8. Alright, 8 cancel out, and I think I can also cancel out the cosine theta, and this power of the cosine has to be 2 squared. So if I rearrange, or if I simplify, sine squared theta d theta over cosine squared theta. And the sine squared theta over cosine squared theta simply becomes tangent squared theta. And you might be at a loss what to do here. Well, the tangent squared theta has a 1 minus secant squared theta. Okay, in case you forgot it, simply use the trig identity, the cosine squared theta plus sine squared theta equal 1, and just divide both sides by cosine squared theta, and you will notice that 1 minus secant squared theta can be achieved. So I'm going to replace it instead of tangent squared theta. So this guy replace that guy. The reason is that 1 is easy to integrate, and secant squared theta, integrating that is going to give you the tangent theta. So one minus secant squared theta, and then you have d theta. So it's gonna be theta minus integral of secant squared theta d theta, and that's simply tangent theta. So theta minus, maybe I should actually shown you how to done this. I just noticed that it should be secant squared theta minus 1, and let me show you why. Okay, I'll show you instead of speaking like that. Well, you know that sine squared theta plus cosine squared theta equal 1. If I divide both sides by cosine squared theta on both sides, I get tangent squared theta plus 1 equal secant squared theta. Because I have tangent squared theta in the integral, I want to keep that intact on the left side, and I can subtract 1 on both sides. So instead of 1 minus x secant squared theta, which I rely too much on my memory, I have to be careful that it should be secant squared theta you see here minus 1. So I apologize, and now I can split in two form. Secant squared theta will be tangent theta, or just imagine that if I take a derivative of tangent theta, it becomes secant squared theta, and then minus theta plus c. But I cannot leave the answer in terms of theta because the given problem was, if you take a look above, this was in terms of dx and x. So how can I convert back to x? Well, take a look at the x equals 2 sine theta. Okay, I'm gonna draw the triangle. So this is gonna play a big role in the last step. If I divide both sides by 2, I get sine theta equals x over 2. Okay, so if you take a look here, x over 2 kind of resembles the opposite over hypotenuse. So if I draw a triangle with a theta, opposite takes x because it's sine theta, and the hypotenuse is 2. And the horizontal just simply becomes, let's see, 4 minus x squared. Well, it's the form you saw above in the problem, 4 minus x squared. Alright, I have a tangent theta which takes the opposite over adjacent. So it simply becomes x over radical 4 minus x squared. Now I have to take the minus here because I have a minus in front of the theta, and the theta itself can be solved by putting inverse on both sides of this sine theta. So for example, if I say, okay, let me copy that one more time, okay, and then say I put the inverse sign on both sides. Basically what I do is a composite function of sine theta with the inverse is gonna simply yield theta. But don't forget to inverse sign on the right side as well. So therefore I have theta equals inverse sine of x over 2. That simply replace the theta, and notice that answers are in terms of x, so we are in good shape. And plus c, and that's our final answer. So this is integral using the trig substitution.